Okay, let's continue on page 3 of the test on Unit 1. So the vase is pictured by the graph, and then we're supposed to record it. As time passes, how high the water is, if water's being poured into this vase at a constant rate. So it's like I put it under the faucet, turn the faucet on, and don't mess with the faucet, so the water's going in constantly. Now, the things you need to notice, this height here, the width of the vase stays the same, and it's pretty narrow. So the water is going to fill pretty quickly through that part until it gets to that height. And I was kind of intended for you to kind of match the height to where we're at. So it's going to go up pretty fast. As time passes, the water level is going up. And then it's going to start at kind of the same speed, which means the same slope, but it's going to slow down. So this should be a continue kind of straight, but then start tapering off until it gets completely full. So that'd be clear up to there. So it's going to go at a constant speed up and then slow down, taking more and more time to fill as you go along. So this should be kind of a smooth transition and curve down, slowing down. This one starts kind of small, so it's going to start going up pretty steep. But in here it gets wider, so it's going to be slowing down when it gets to this height. And after it gets to that height, it's going to be speeding up, and it gets to be the same width as this is. And so the steepness here should be the steepness it ends at to get it to a full vase. So it should start off going fast, steep slope, then slowing down. The rate of change is high, decreases because it's wider, and then it increases again back to the steepness, the rate of change at the beginning. So this slope and this slope should be about the same. And it should be a smooth curve because it gets gradually bigger, then gradually narrower. This one starts kind of wide, so it's going to start kind of slow. And then as it goes up, it gets narrower, and it's going to start getting faster all the way through to here. And then it's pretty much the same there and pretty thin, so it's going to continue smooth curve, not a sharp bend. Whatever speed it got to here, it's pretty much going to hold that speed the rest of the time, going straight till it gets to the top. All right. 25 miles per gallon. 25 miles per gallon. If we multiply this by the number of gallons, the gallons would cancel and I'd get miles, which is distance. So 25 times the number of gallons, if we say that's G, 25G will give us miles. So a function that starts with 25 times G and gives us a distance would be this one. So this has got to be 25G. Start with the number of gallons, multiply by 25 miles per gallon, and I get the distance. This one is 65 miles per hour. So if I multiply by the number of hours, which is time, 65 times the time, hours, the hours cancel, and I get miles. So which one takes T and gives us distance? This one. So this has got to be 65 t. 65 miles per hour times the number of hours, and it'll give me the miles. Now, if I'm going to reverse these two, instead of d of t, this is like having d equals 65t. If I want to reverse it, I'm going to have to divide by 65 and divide by 65. And the time is the distance divided by 65. The distance divided by 65 gives me the time. And this one reversed is going to similarly, this is d equals 25g. So if I divide by 25, I get the gallons is the distance, the independent variable distance. If I take that and divide by 25, I will get the number of gallons. So there's this answer, this answer, this answer, and this answer. These are equal in there. Some of you didn't put that in. I didn't count off. I should have, but I didn't. Now, I got to start with time and end up with gallons. This is the only one that ends up with gallons, and it's equal to d over 25, but I want to start with time. Well, if I start with time here, I can get the d. So the d that this needs is going to be 65t, gives me a d, and d divided by 25 gives me a g. So that's how you get that one. It is g of d of t. So d of t put in place of the d here and gives me g. All right, 7, domain. If we just type this in either Desmos or the calculator, 1 plus square root of 4 minus 2x, and go zoom 6, it says we get y values for any x value negative infinity up till 2. From negative infinity up till 2. Can I use 2? 2 times 2 is 4. 4 minus 4 is 0. Can I take the square root of 0? Yes, it is 0. So I can use 2. The other way to get that is, the problem is a square root of negatives. So we want 4 minus 2x to not be negative, positive or 0. And if I solve this for x, by subtracting 4, I get negative 2x greater and equal to negative 4. Subtract 4, subtract 4. That's still negative on this. Divide by negative 2. And dividing by a negative will cause the sign to flip, and the negatives will cancel, and I get x is less than or equal to negative 4 divided by negative 2 is positive 2, which is what that is. And I could have typed this into Desmos. Let me do that for you, because some of you don't see where the square root comes from. So over here, we're going to type in, get up in the right position here, camera. So I want to do y equals 1 plus the square root. We have to go down to the bottom. And again, on this little, where's my mouse? The keyboard thing, if I click on it, I get the square root, and then I've got to do, what was it? 4 minus 2x. x. And you can see that graph goes all the way up till 2 and stops from negative infinity till 2. And you have to kind of decide whether you can use 2 or not, whether that's an open end or not. Okay, number 2, or part B, R. Well, this has got division, so this can't use division by 0. So x can't be 2. So it's all reals except 2, because 2 minus 2 would be 0. Now, if I want to do interval notation, it would be from negative infinity up till 2, not including, union from 2 to infinity, not including 2. Infinities are always open. You could do it with inequalities too. It would be x is less than 2, or x is greater than 2, just not equal to 2. You could also say x is not equal to 2. This answer would be acceptable, that answer would be acceptable, that answer would be acceptable. That answer. Now this one, this is a little bit more complicated. The square root of 0 is 0, and we can't use division by 0. So whatever makes this denominator 0 has got to be thrown out. Well, something squared minus 1, so what squared is 1? Well, 1 squared is 1, so we don't want to use 1. But negative 1 also squared is 1. So we got to not use 1 at negative 1. They've got to be gone. But there also can't be negative. So if I write x squared minus 1 has to be greater than 0 and add 1 to both sides, I get x squared is greater than 1. Well, I want it to be greater than 1. So if I use something smaller than 1 in here and square it, I won't get greater than 1. Another way to look at this is look at the x squared minus 1. And if I look at that, x squared minus 1, it's negative between minus 1 and 1. And we can't have a negative. Can't do the square roots of negative. So it's positive below 1, negative 1, and above 1. So I can use those, but I can't use between there. So I can't use 1 and negative 1, and I can't use the numbers in between. So I can use from negative infinity up to negative 1, not including the 1. Or I can go from 1 to infinity. Now, you can see that if you graph the whole thing, which is, clear this, on the newer calculators, you can do a fraction. You can go alpha y equal, enter, and it'll make a fraction thing for you. The older ones, it doesn't, so you have to put the numerator in parentheses and the denominator in parentheses. I'll do it like I'd have to do it on the older one, but this is easier. I'll clear it and I'll go parenthesis for my numerator, x plus 2, close parenthesis, divided by, and then, oh, excuse me, doing the wrong problem here. Clear. Parenthesis, 2x minus 5, close parenthesis, divided by parenthesis, square root of x squared minus 1, close parenthesis. Oop, on the outside. Delete, go to the outside parenthesis. That's kind of how you would type it in on the older calculator. And the older calculator would put a parenthesis here, so you'd just put a parenthesis at the end. But anyway, Zoom 6. Notice that it's getting values for all these x's. It's getting y heights. But at -1, it disappears, and at +1, it's not there. It starts after there. It skips over this middle part. It's kind of hard to see it here, but it's got a part where there's no graph. It looks like it might be something. We can look down lower. We can look to -100, and you can see it disappears at -1 and reappears at 1. You can trace and try to follow it. There it is. And as I get closer and closer to -1, it disappears. And it shows up again. If I'm moving, pushing to the right here, and it shows up again here, right around 1. Hard to tell where it disappears and reappears on the calculator. That's why you kind of need to be able to look at this and figure out 1 and -1 are where it's 0. Can't have 0 because that would be division by 0. But it can't be the in-between part because the parabola gets below 0. Okay? Now, I could have done the same thing on Desmos. You saw it. Let's do this one. So now we got composite function. So it has to pass through f first. So that means we can only use numbers from -infinity up to 2, including 2 in this. So what are the possible domain is already shrunk. We're shrinking it down what we can use. And then what comes out of this, the y value, has to go into R. Well, R can't accept 2. So if we look at this, we want the 1 minus the square root of 4 minus 2x to not be 2. So if I subtract 1 from both sides, I get negative square root of 4 minus 2x to not equal 1. If I multiply both sides by a negative, I get the square root of 4 minus 2x to not equal -1. Then if I square both sides, I get 4 minus 2x cannot equal -1 squared is 1. If I subtract 4 from both sides, I get -2x cannot equal -3. And if I divide by -2, I get x cannot equal -3 divided by -2 is positive 3/2 or 1.5. X cannot equal 1.5. If I put 1.5 into here, take it times 2, I get 3. 4 minus 3 is 1. Square root of 1 is 1. Plus 1 is 2, which I can't use. So remember, it had to go into f of x, so it can only be numbers from -infinity up to 2, but it also can't be 1.5, so it's going to be -infinity up to 1.5, skip over that. So don't include 1.5, don't include 1.5, but get up to 2. And we can use 2 because 2 would give us 1, and 1 works in there. So that's D. A little bit complicated. And finally, E. Well, if I'm going to do square root of x, the only thing I can use in here would be 0 to infinity, positive numbers, or 0, just non-negative, can't be negative. It has to pass through the first gate, the square root of x. But then what I get out, the square root of the x, cannot equal, what can't I use in R? 2. So if I square both sides, I get x cannot equal 4. So I got to be somewhere between 0 and infinity, but not 4. So it's going to go from 0 to 4, skip over 4, and go from 4 to infinity. Now, let's do this one on Desmos. So, let's get there. Okay, so I'm going to erase this. It had to go through the square root, which is down in this keypad at the bottom. If I click on that keypad right, holding that mouse there and try to get the other mouse to go there, or hold the camera there, click on it, and I can get the square root. I had to have the square root of x, which has a domain of, come on, stay in the right position there, camera, has a domain of 0 or bigger. I can use those and get y values. Now the y values I get out have to go into the other one, which is r of x. And what r of x is, it can't have a value coming into it. So the y value coming out of this has to go in there. So the y value cannot equal 2. So what x going into the square root produces 2, and that is 4. So I can't use 4. So that gets us back to what we had. Can't use 4. What comes out of the square root has to go in for the x, and the square root of 4 is 2. We can't use it. Okay, final page. Somebody just knocked on my door, so I hope I'm not being rude and not paying attention to them. Okay. It said, ooh, I got to go to class. I'll have to do this page separately.